The sound of a V10 engine is unlike anything else. Its sharp resonance flows out of the exhaust pipes, cuts through the air, and shakes our eardrums with a unique harmony. By nature, the layout is imperfect. Two banks of 5 cylinders constantly fighting each other in a mechanical tug-of-war. Physics suggests it shouldn't run so smoothly, yet with clever engineering, it not only works, but produces one of the most intoxicating sounds ever heard in motorsport. Back in 1997, BMW's motorsport division began its pursuit of perfection with the V10, not for showrooms, but with a singular mission: conquering Formula One. This wasn't about reusing existing parts or modifying production engines. It was a bold step into uncharted territory. Their investment in research, materials, and tooling wouldn't just produce competition-spec engines, but also pave the way for one of the most legendary road cars ever to wear the BMW badge. For the first time, the company would unleash a naturally aspirated road-going V10 capable of spinning past 8,000 RPM straight from the factory, a true declaration of a new era. To understand how this came about, we need to look back at BMW's earlier presence in Formula One. During the 1980s, the company made headlines with a turbocharged F1 engine that remains one of the most powerful the sport has ever seen. Conceived by Paul Roche, technical director at BMWMotorsport, it was a 1.5-liter, 4-cylinder twin-cam design based on a basic iron block, but with a massive triple K turbocharger pushing over 5.5 bar of boost, it delivered nearly 1,300 horsepower in qualifying trim. Installed in Gordon Murray's Brabham BT53, it carried Nelson Piquet to the 1983 Formula One World Championship. But extreme performance came with consequences. The M12 engine was notoriously thirsty, plagued by brutal turbo lag, and so highly stressed that reliability became a constant gamble. Even so, BMW's partnership in the sport produced 9 wins, 15 pole positions, 14 fastest laps, and a world title before the company pulled out of Formula One at the end of 1986. When the FIA eventually banned turbo engines, BMW's chapter in the sport seemed closed. That silence lasted a decade. Then in September 1997, rumors of BMW's return became a reality. Having already collaborated with Gordon Murray on the McLaren F1's S70 V12, Paul Roche now turned his attention to a new challenge: designing a Formula One engine for the modern era. Under FIA regulations, manufacturers had freedom in cylinder count, yet most gravitated toward the naturally aspirated 3.0-liter V10, the sweet spot between the compactness of a V8 and the smoothness of a V12. But engineering a V10 was no easy task. The layout suffered from inherent imbalance, creating vibrations that could upset the chassis. A 72-degree bank angle was the natural fit, but it made the engine taller, raising the car's center of gravity. Ferrari solved this by adopting a 90-degree V10, which kept the weight lower while smoothing out the harsher harmonics through complex tuning. BMW followed a similar path. Their first Formula One V10, the E41, debuted in the year 2000. Installed in the Williams FW20, it produced 810 horsepower and immediately put the team on the podium, finishing third in the Constructors' Championship behind McLaren and Ferrari, a remarkable achievement for a manufacturer that had been out of F1 for over a decade. The next generation came quickly. The P80 V10 adopted a 90-degree bank angle like Ferrari's, shaved 12 kilograms from its predecessor, revved higher to 18,000 RPM, and pushed output to around 880 horsepower. It carried Williams to 4 race wins, but still left them third overall in the championship. BMW's subsequent engines, the P82, P83, and P84, delivered incremental improvements in power and weight. Yet, despite these advances, Ferrari and Michael Schumacher dominated the era, stacking world titles year after year. Although BMW never achieved ultimate glory in F1, their massive investment left behind something even more valuable. They had built a state-of-the-art engine facility capable of precision alloy casting, developed in-house electronics and prototype manufacturing processes, and assembled a team of elite engineers. These foundations would soon be directed toward an entirely different mission: creating a road car that carried Formula One technology straight onto public streets.
Building something remarkable always requires a team of dedicated minds. That's true whether you're designing a car, creating an idea, or simply trying to improve everyday life. While BMW's engineers were buried in the complexities of motorsport technology, another project was moving forward, quietly: the replacement for the E39 5 Series. Under the direction of Chris Bangle, chief of BMW design, stylist Davide Arcangeli envisioned a bold new approach. Instead of evolving the existing shape, the plan was to reinvent the 5 Series entirely. Tragically, Arcangeli passed away from leukemia shortly after his concept was approved, never seeing the vehicle that would become the foundation of the next M5. Behind closed doors, BMW engineers were also working on a new power plant unlike anything that had come before it. This engine, known as the S85B50, was a direct descendant of lessons learned in Formula One. Borrowing heavily from the P8X race units, it featured a 90-degree V10 layout to keep the center of gravity low. The block was a 2-piece aluminum silicon alloy design with a bed plate for extra rigidity, echoing construction methods from the E41 Formula One engine. Its crankshaft received a nitriding treatment for durability, and while steel connecting rods replaced the exotic titanium used in racing, the pistons retained F1-derived coatings to reduce friction. Compression was set at an aggressive 12-to-1. The architecture was equally advanced up top, with dual overhead cams, 4 valves per cylinder, and titanium exhaust valves to withstand extreme heat. The design pushed naturally aspirated performance to its limits. BMW's double Vanos system offered wide adjustment ranges on both intake and exhaust sides, while each cylinder was fed by its own throttle body hidden beneath dual intake plenums. Hydroformed headers merged into equal-length collectors to balance flow. The result was staggering: 507 metric horsepower at 7,750 RPM with an ear-piercing redline of 8,250 RPM. Torque was modest due to the oversquare design, but paired with a 7-speed sequential SMG gearbox, the power band never felt lacking. The E60 M5 was soon joined by its sibling, the E63 M6 Coupe. Slightly lighter but equally imposing, both models were designed as high-speed Autobahn weapons rather than lightweight track scalpel rivals to the Porsche 911. With the optional M driver's package, top speed was limited to 305 km per hour, and unrestricted the cars could flirt with 320 km per hour. Upon release, the M5 instantly became the fastest sedan money could buy. These machines were the epitome of German over-engineering, a final chapter in BMW's most ambitious era. But pushing Formula One technology onto the street came at a cost. During the standard 4-year, 80,000-kilometer warranty, countless owners faced major mechanical issues. Early versions of the high-pressure oiling system for variable valve timing were prone to failure, prompting service updates. The oil pan had to be redesigned with dual drains for proper maintenance. Even the Vanos solenoids needed stronger replacements by 2006. The most infamous issue, however, was premature rod bearing wear. Designed with extremely tight tolerances and dependent on high zinc engine oils, the bearings often failed when subjected to BMW's long oil change intervals or to modern oils with reduced zinc levels. This combination left many engines at risk, giving the S85 a reputation as both brilliant and fragile. As these cars aged and their market value dropped, enthusiasts flocked to them for the thrill of an F1-inspired V10 drivetrain. But ownership costs quickly matched the nightmares once associated with early 2000s Italian exotics. The S85 could have gone even further had BMW followed through with prototypes developed in 2009. One such project was the stroked 5.5-liter S85B55, featuring a massive carbon intake plenum, an 8,750 RPM redline, and output estimated near 600 horsepower. In CSL form, paired with a newer dual-clutch transmission, lighter forged wheels, and a carbon roof, the car lapped the Nürburgring over 20 seconds faster than the standard M5. Yet, the project never reached production. Looking back, the E60 M5 stands apart as an anomaly in BMW's history. It was too wild to be a traditional executive express, too ambitious to be truly practical. Marketing positioned it against supercars like the Porsche 911 and Lamborghini Gallardo, an unusual benchmark for a sedan. Its successor, the F10 M5, returned to a more conventional formula, faster, more refined, and easier to live with. But the E60 represented the daring what-if era for BMW. What if an F1 V10 belonged in a family sedan? What if red lines stretched past 8,000 RPM? What if maintenance was the price of exotic performance? Today, BMW has no real stake in Formula One, but those who remember the company's V10 experiment know it left behind one of the most unforgettable chapters in performance car history.